134. Come on. In the previous class, we were discussing about salt hydrolysis. We have said that salt hydrolysis is a process in which when you add salt into water, resulting solution exhibits acidic, basic or neutral properties. This is known as salt hydrolysis. People say something like this, but it is not that way. The hydrolysis means combination of ions of salt, and that to be which type of combination? Selective combination. Selective combination of salt, ions of salt with ions of water. This process is known as salt hydrolysis. And to enjoy the beauty of this definition, let us try to understand very basically and systematically what is the real meaning of word selectively reacting, right? Ions of salt and ions of water are selectively reacting. Come on, for that purpose, let us take an example. Suppose, for example, if I am having A plus B. Yesterday, I think I have shown you that one. Is it shown to you? No. We are having a salt, say for example, sodium chloride salt. I'll classify like this. Salt of weak acid and strong base. Okay. Now I'm combining the discussion. When you are saying that it is supposed to be of a selective combination of ions of salt with ions of water, remember that you can classify salt hydrolysis like this. Of A, salt of weak acid, strong base. B, salt of weak base and strong acid. C, salt of strong acid and strong base. Salt of weak acid and weak base. Weak acid and weak base. There are only 3 types of hydrolysis. Remember that. 4th type does not exist. Some books says that there are 4 types of salt hydrolysis. It is wrong. We have only 3 types of hydrolysis, salt hydrolysis. They say something like this, that there are 4 types of salt hydrolysis, and they come to D, salt of a strong acid and strong base. Then they use the word, there is no true hydrolysis. There is no true and false here. Hydrolysis takes place, full stop. Hydrolysis does not take place, full stop. Finished. Right? So there are only 3 cases available. Come on, now try to understand what is the meaning of hydrolysis of salt of weak acid and strong base. For this purpose, let us try to understand the steps which we have to teach as a teacher and the steps which you have to learn when you are doing study hours. Come on, case number 1. Hydrolysis of salt of weak acid and dash strong base. Weak acid and strong base. Come on. How to proceed that? The steps are like this. Step number 1. First of all, try to understand who are those fellows. Right? The first examples are necessary here because in examination they'll ask you only with respect to simply example only, right? Come on. When you are having this one, weak acid, strong base. Weak acid, all organic acids are weak acids, and strong base, all first group metal hydroxides. Second group metal hydroxides are strong bases. Therefore, you can take example of any one case, right? Let us try to understand something. I'll give you some examples. You people are genius. You can create so many other examples. For example, formic acid along with sodium hydroxide, sodium formate. Weak acid, strong base. Acetic acid along with sodium hydroxide, along with potassium hydroxide, potassium acetate, sodium acetate, etc. No, sir, I am having oxalic acid along with sodium hydroxide, sodium oxalate. Yes, it is also correct. No, sir, I am having benzoic acid is weak acid, potassium benzoate. Right. Similarly, phenols, what your Krishna Mohan sir says, phenols are acidic in nature and alcohols are neutral. So if it is so, sodium phenoxide, right? Like this. These are all organic acids I have taken. Why don't you go for inorganic, sir? Okay, no problem. HCl, sodium cyanide, calcium, let us take calcium cyanide, right? This is coming from weak acid, hydrogen cyanide. This is calcium hydroxide. Next, say for example, calcium sulfide, calcium hydroxide, H2S. Magnesium, weak acid. Let us take weak acid, any weak acid. Magnesium phosphate, Mg3PO4 taken twice. Who is phosphoric acid? Weak acid. Who is magnesium hydroxide? Strong hydroxide, right? Strong base. Okay. Barium acetate, formate. So all the things, anything you can use in case of weak acid. No, sir, I am talking about inorganic acid. Barium carbonate. Carbonic acid is weak acid and barium hydroxide is a strong base, right? There is no limit for such examples. We have to go on thinking and go on writing to have more and more practice of this one, because that fellow say only give that name. He will give the name and he'll ask you what is the nature of this solution, acidic, basic or neutral. Only that information is sufficient to give 4 marks to you, right? Come on. Now, second point, what we have to remember first is what are the examples. Second point is what is the meaning of salt hydrolysis, that I am insisting upon you, that selective reaction between ions of salt and ions of water. For that purpose, what we do, suppose for example, if I have taken this fellow, who is that? Sodium acetate. Let us take this for reference. CH3COOH and sodium hydroxide, sodium acetate, weak acid, acetic acid, strong base, sodium hydroxide. Now, if suppose, for example, you have taken hydrolysis, means you have taken aqueous solution, then what happens? You are having CH3COO minus acetate ion along with formation of sodium ion. These two fellows are dancing in the container. Now hydrolysis. What is the meaning of hydrolysis? Try to understand here. It will give you H plus ion and it will give you OH minus ion. Of course, the number of H plus and OH minus ions are very less because it is a weak electrolyte. Now, in the container, we are having acetate ion along with sodium ions, H plus ion along with OH minus ion. So once the reaction starts, then what happens? This acetate ion, listen carefully, the concept. Acetate ion says to H plus ion, I am coming from weak acid. I am coming from weak acid. And being conjugate base of weak acid, I am very strong. Therefore, I love you. Hence, let us enjoy life. They will combine together and there is a formation of dash CH3COOH. Since it is a weak electrolyte, there will be an equilibrium process. Hence, we should write this type of discussion. Sir, we are having this. What is happening here? Acetate ion is getting combined with H plus ion. This combination is known as salt hydrolysis. Selective ions of salt reacts with ions of water, whereas Na plus ion says to OH minus ion, okay, I am coming from strong family, rich family, I want to enjoy my life separately, I don't want to combine with you. Therefore, what will be available? Na plus ion is individually available along with separate OH minus ion. Who is combining? Acetate ion. Who is not combining? Sodium ion. Hence, this combination is called hydrolysis. Okay. Now, the question is, if it is so, who is undergoing hydrolysis? Acetate ion. No, no, negative ion. Okay, this implies anionic hydrolysis. The name 4 marks question for doctors. It is called anionic hydrolysis. If it is anionic hydrolysis, implies anion of salt is combining with water. Anion of salt is combining with water. Anion of salt is combining with water. Naturally, when anion will combine, it will not combine with anion of water. It will combine with cation of water. Hence, OH minus ion is left out free. When OH minus ion is left out free, solution becomes basic in nature. Yes. Question is, in which case we have basic solution? Anionic hydrolysis results OH minus ion in excess quantity. Therefore, this implies solution is basic in nature. That word is very much clear in when you write heading itself. When you say strong base, here answer is over. Solution is basic. Question is not what solution is basic or acidic. So question is which ion is responsible to undergo hydrolysis so that it is becoming basic, right? So that is anionic hydrolysis. OH minus ion will be left out as it is. This means I don't want to go into so many examples because you people are genius. Therefore, this one example is sufficient to you. But when you think starting properly and studying at home, then what we can say, sir? Okay, it means to say only those ions will undergo hydrolysis which are belonging of weak electrolyte. Yes, you are right. Remember that ions of weak electrolyte undergo hydrolysis. Ions of strong electrolyte never undergo hydrolysis because a salt consists of always one acid and one base. Therefore, if you are having weak acid, anionic hydrolysis. If you are having weak base, cationic hydrolysis. If you are having both weak acid and weak base, hydrolysis of both weak electrolytes, because basically hydrolysis is the property of weak electrolytes. Hydrolysis is not the property of strong electrolytes. Therefore, there is no chance of fourth case. What is that? Hydrolysis of strong acid and strong base salt. No chance of hydrolysis. Why it is not undergoing hydrolysis? We'll discuss in a typical way at the end of this discussion. Come on. If suppose you are having this one, then we can say, sir, okay, fine. I understood what is the meaning of salt hydrolysis. I understood what are the examples of salt of weak acid and weak strong base. And I also understood what is the meaning of hydrolysis, who is undergoing hydrolysis, and what is the nature of the solution. It is basic in nature. pH is more than 7. Theoretical part. Now turn the photograph. What is that? Numerical approach, right? If suppose, for example, you are having the solution to be basic in nature, how to calculate the pH of solution? Okay, for that we'll discuss later on. Complete this first. Copy down this. If it is over, intimate me. I'll go back further. Come on. Now our next job is a numerical approach. How to proceed for this? Very simple, sir. Let us enjoy the game like this. Suppose, for example, consider hydrolysis of what? Sodium acetate, CH3COONA. Right? What you have said? Weak acid and dash. Strong base. Come on. CH3COO minus Na plus combines with water so as to give you CH3COOH. This is hydrolysis. This is hydrolysis. It is selective ion of salt is combining with ions of water. Now, what is left out? Na plus. What is left out? OH minus. Right. Now, the question is, sir, Na plus is available in the left-hand side part. Na plus is available here in this case. That means, remember that in case of hydrolysis, those ions will never participate which are coming from strong electrolytes. Only hydrolysis word is meaningful when we are discussing with components coming from weak electrolyte. Okay. If it is so, then how to proceed? Let concentration time t is equal to 0. Concentration of acetic acid is supposed to be C. Here in this case, we are having something. Okay. I'll give you separate equation. How to proceed? Very simple, sir. We are having CH3COO minus plus what happened? H plus gives you CH3COOH and dash. What? This OH minus ion. This OH minus ion coming from water. So I have to write here water so that you can understand properly. To give OH minus ion. At time t is equal to 0, concentration of salt C. Concentration of salt is taken as C. If it is so, then this is 0, this is 0. Be careful, be careful. Time t is equal to t, C into 1 minus alpha. As you said in the previous classes, C into 1 minus alpha. Therefore, here we write this to be as C into 1 minus alpha. In place of alpha, we write H. What was alpha? Degree of dissociation. Here, degree of hydrolysis. H is known as degree of hydrolysis. Therefore, this is CH and this is also CH. Now, let us go for discussion, sir. We are talking about something known as K. What was that? Ka we have done acid ionization constant, Kb base ionization constant, Kw ionic product of water. Now it is called Kh. What is this? Hydrolysis constant. It is known as hydrolysis constant. Hydrolysis constant may be written as concentration of acetic acid formed into concentration of OH minus ion by concentration of CH3COO minus. Active mass of water, you know very well, it is taken. Now, this is equal to, shall I write in this form? C square H square by C into 1 minus H. This is called C square. You can recall that Ostwald dilution law. Okay, sir, we are getting similar type of expressions. KH is equal to CH square by 1 minus H. No, sir, this is the story of weak electrolytes. Therefore, we can say since acid is weak, therefore, degree of hydrolysis is to be very much less than 1. Hence, we can neglect degree of hydrolysis as compared to 1. And therefore, we say that KH is equal to CH square. Okay. Now recall degree of dissociation under root K by C. Similarly, degree of hydrolysis is equal to under root KH by C. Yes. Right? degree of hydrolysis H, small h is known as degree of hydrolysis. This is known as hydrolysis constant. Be careful because some of you may do mistake. Commonly it is a mistake. People will say something for this and something for that. H is known as degree of hydrolysis and KH is hydrolysis constant as equilibrium constant. C is concentration of salt. Be careful. It is concentration of salt. Now I am saying it is concentration of salt. After some time, I'll change my way of saying. Take care of that and try to catch that point. Come on. If you are saying H is equal to under root KH by C, then there is a problem here. What is the problem? Sir, wherever we are writing this type of representation, what is that? We are writing equilibrium symbol. It is applicable in the system, in the reaction vessel. Anybody who is having weak, I can apply to that one, right? So here it is hydrolysis process, but once you have hydrolysis, acetic acid is formed. So there is no chance of acetic acid to enjoy like molecular state. Being a weak electrolyte, it will undergo dash ionization, CH3, COO minus and dash H plus. For this, what we can write? We can write this to be as Ka. Ka is equal to concentration of acetate ion into concentration of H plus ion by concentration of acetic acid. Okay. This is equation number 1. This is equation number 2. I am trying to relate this equation, this part of equation. Sir, there is one more weak electrolyte in the container. Who is that fellow? Our green friend of us, known as water molecule. It will give you H plus and OH minus. If it is so, then we say it is Kw is equal to concentration of H plus ion into concentration of OH minus ion. This implies that whenever we are discussing the salt hydrolysis, we have to consider all the possible equilibria in the container. Right. Now see the equations carefully and tell me what has to be done to equation number 2 and 3 so that I can get equation 1. What is that equation 1? This is equation 1 corresponding to this one. So manipulate equation 2 and equation 3. This equation and this equation, I'll write it. This equation and this equation we have to manipulate so as to get this equation, this one. Or you say something, sir, I will take any two to manipulate third one. No problem, go ahead. If you do so, we'll get something, and that something is KH is equal to KW by KA. Try this at home, right? KH is equal to KW by KA. Right? Once you understand this, then we can say, sir, H is equal to under root KH. No. KW by KA into C. This you have to memorize. This we have to learn. Remember, if suppose, for example, you are saying something like this, then we can proceed. H is equal to under root KW by K into C. This is very important because from this we can have number of conclusions. Conclusion number 1. What are the factors upon which H depends? Remember, dependence of H. What is H? Degree of hydrolysis. Number 1. Definitely you have to say, sir, it is nature of electrolyte. Definitely. Nature of electrolyte. I don't use the word nature of electrolyte because we are having heading salt hydrolysis, nature of salt. Next, right? You cannot say nature of solvent here because you are saying the word hydrolysis. Water should be used here. Therefore, there is no discussion of nature of solvent. Next, right? H is inversely proportional to root concentration. No, sir. H is directly proportional to dilution. Is it not? Duplication of your Ostwald dilution law? Yes, we are saying same statement. That means degree of hydrolysis is directly proportional to as dilution increases. Degree of hydrolysis also increases. Remember this point. Next, sir, it depends upon Ka value, right? How it depends upon Ka value? H is inversely proportional to root of Ka. What is the meaning of that? As Ka decreases, okay, let us enjoy this word, increases. Now, what is the meaning of K increases? K increases means acid is becoming strong and strong and strong. I am not discussing about strong electrolyte. My topic is with respect to weak fellows. Therefore, as K increases, relative strength of the acid increases, and as the strength increases, that fellow denies to undergo hydrolysis. I know I don't want to undergo hydrolysis because I am a rich fellow. Therefore, hydrolysis is the property of weak substances. Therefore, remember, doctors, as K increases, what happens to pKa? Decreases. You have to relate this one and this one. They'll give you different substances and they'll give you Ka values, and they ask you decreasing order of degree of hydrolysis or increasing order. That you have to enjoy beautifully this part. Next, when we are talking about degree of hydrolysis dependence upon this one, then the question is not this one, sir. Our question is how to find out pH. By the way, we are getting so many 4 marks question, but our ultimate question is what is the value of pH. Naturally, when you want to find out the value of pH, you have to search where is H plus ion, right? Is it available? No, sir, we don't have H plus ion. We are having OH minus ion available here. No, no, no. Here we are having H plus ion available. Therefore, we can take advantage of either this equation or this equation. Come on. Since I am saying solution is basic in nature, therefore, I should take concentration of which ion? OH minus ion. Be careful. Concept should be strong here. We have OH minus ion, we have H plus ion, but we are talking about basic solution. What is OH minus ion concentration? CH. Okay. No, 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 sir, not CH. This is equal to CH. What is CH? Kw by Ka into C. If you simplify, OH minus ion is equal to under root Kw into C by Ka. This also you have to remember. You are not a parrot. You have to make practice in such a way that, yes, sir, I can understand by practice. And once you are having this value, then you can say, sir, my job is to enjoy what? pH value. Okay. Once you have this one, then go for pOH. I'm having less space, but I'll try to manage the situation. pOH. How to proceed? Apply log of OH minus ion is equal to half. You people are genius. Log of Kw. Are you able to visualize the screen after white color? Is it visible? Should I write there? Yes, very good. Log of Kw plus, right? Thank you. Log of C minus log of Ka. Okay, sir. Log of OH minus ion is equal to root half log of Kw into plus log C divided by minus log K. I don't want log, sir. I want pH. Okay, multiply by minus sign, multiply by minus sign, and minus sign. If you multiply throughout by negative, then it becomes minus log of OH. You people are genius. Okay, sir, I got pOH is equal to half minus log Kw, pKw. Very good. Then minus log K, I'm writing this first. Minus log K, pKa. Then minus log C, there is no P, log C as it is. And what is C? C is concentration of salt. Okay, I got it. No, 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 sir. I want to talk about pOH value. I don't have space now. Write down this, then we'll proceed to the next slide. write down comfortably separately. Don't make a mix up like this. I don't have space on the screen, but you have to write very systematically, line by line, separately. POH is equal to half pKw plus pKa, because minus log Ka. I have not taken that minus into account here. Yes, you are correct. This minus I have not taken into account. This is minus, therefore, this minus log K is pK, but there is a minus here. You are right. Is it over? Okay, go ahead, go ahead. If it is over, Now we are having POH. No. I want pH. Then if pH is required, what do you know? pH plus POH is always equal to 14. Therefore, this implies pH is equal to 14. Take care of a minus sign, right? I am forgetting sometime that one. 14 minus half pKw minus of minus plus half pKa minus of minus plus log C. Some people say like this. Some people say, sir, don't open it as a whole because there will be a beautiful, meaningful equation comes here. If you don't open the whole equation, this is fine, correct. But if you don't open it completely, see what happens. 14 minus half pKw, right? Minus, keep it inside, right? Now we have taken this minus half and this is minus. What is left out here in this case? pKa half. I should take here again one more time half. Half and something. Now 14 minus what is pKw? pKw is 14, right? Because pH plus pOH is equal to pKw. Half into 14, 7. Okay. This is 7 minus, when we are discussing this, half into something. Suppose, for example, if you say, sir, I don't want to take this minus into account. If you want to make it as a plus, then plus, come on. Tell me what will be the situation? pKa, right? And this is log C. Please check my symbols there. We got some equation pH is equal to 7 plus half into log of pK minus log C. Please check once again. I'm saying, okay. Now I am having this story to enjoy. What is that? Sir, whatever be the answer available here, there will be some number, but this is 7 plus that number, 7 plus that number, right? Go back to discussion of first page. What was that? pH must be more than 7. Yes, pH is more than 7. Therefore, pH is equal to 7 plus half of some number, but that number should be pK minus log C. What is this C? This is very important. This is concentration of salt. Again, I am saying wrong thing here, but now I'll prefer this wrong statement. I'll rectify that later on. Okay, concentration of salt. In books, you're having concentration of salt only, but this is not correct. Why it is not correct and what is correct statement? Come on, see here. Suppose, for example, you are saying, sir, I have taken CH3COONA. Right? This is salt. Suppose, for example, the concentration is C, as we have done in buffer. Same story here. Suppose, for example, if it is so, this implies who is undergoing hydrolysis? Sodium ion or acetate ion? I don't care about sodium ion, sir. Therefore, I'll take care of this fellow. Concentration of acetate ion is equal to C. Therefore, people say this C is concentration of salt. No, because if you take this salt, okay, calcium acetate, is it not salt of weak acid strong base? Yes. If suppose you are having that type of story, then the problem will be of different style. What is that? If concentration of calcium acetate is equal to C, what is concentration of the ion which undergo hydrolysis? This is dash 2C. Therefore, I should not use the word C is concentration of salt. What I should say precisely, this is supposed to be concentration of that ion, yes, which undergoes hydrolysis. It's not salt. It's not salt. Okay. In some cases, whenever you're having binary salt, 1:1 type of salt, where valency factor is 1, you can enjoy that this is salt. IP books say this is salt. Go ahead. Because in IP, we are having 1:1 story. But when you go to NEET and mains examination, it may be any other salt, especially for advanced questions. It will be definitely this type of salt. In that case, this C stands for concentration of that ion which undergo hydrolysis. You've done that. Anywhere, if you are feeling difficulty with science, please go systematically. I may be jumping at some step. I'm having that bad habit. You go one by one, one by, and then you say, sir, yes, it is correct. No, no, sir, this is wrong. We have to have changed the sign. You do it systematically. Okay, no problem. Jasin saying that in pH last sign line, this line, he's saying that pK plus log of concentration of salt plus, check up that one. If it is so, I'll go ahead, no problem. Anybody tell me? Very good, no problem. Nice. And where is my concentration? My concentration is this plus, right? Why? 7 plus something. We are discussing about 7 plus something, therefore pH value will be always more, right? Than 7. Go ahead. Very good. Okay. Shall I remove? Is it over? No. Let us go for the second discussion. Hydrolysis of salt. Let me enjoy this story like this. Hydrolysis of salt of strong acid and weak base. Right. Question number 1. Same thing, sir. What are the examples? Weak acids, sorry, strong acids. HCl, HSO4, H2SO4, HNO3. There are so many acids, you know it. Weak bases, right? Ammonium hydroxide along with HCl, ammonium chloride. Ammonium hydroxide along with sulfuric acid, ammonium sulfate. Ammonium hydroxide along with nitric acid, ammonium nitrate. Zinc hydroxide along with HCl, zinc hydroxide along with sulfuric acid, copper hydroxide along with nitric acid. Okay, like that. Then ammonium hydroxide HClO4, ammonium perchlorate, very strong acid and very weak base. Like this, we are having so many cases. Come on, next step. Who is undergoing hydrolysis? Let us take this fellow, ammonium chloride, dissociates to give you ammonium ion along with dash Cl minus ion. Now you are saying, sir, let us add water. Water will give H plus ion, OH minus ion. I'm writing in an order here. Now, ammonium ion. Who is the source? Weak base. Therefore, ammonium ion says, come on, OH minus ion, let us enjoy a game. And this game is known as salt hydrolysis. Selective ion of salt react with the ions of water. Which is selective ion? Cation. Okay, okay. This implies cationic hydrolysis. If cationic hydrolysis takes place, the cation of salt should react with anion of water. Hence, this H plus ion. H plus ion is saying, hi, how are you? It's chloride ion. She says, I am coming from strong family. I don't want to have any attachment from your side. Therefore, due to cationic hydrolysis, H plus ions are free. This implies cation of salt never combines with cation of water. Therefore, solution is dash. Strong acid. Yes, sir. Solution is acidic in nature. And this implies pH must be less than 7. That is my job. What is your job? Just see first case, write down all the things systematically, and then get the expression for H, get the expressions for KH, right? What is that? KH is equal to, what was that? Under root KW by KA into C. A, if acid is weak, A, cheating. If base is weak, oh, come on, KW into, you should get this equation, KB into C, right? Then here we have acidic solution. We get H plus ion concentration left out is equal to C alpha. No, sir, CH. Therefore, it is supposed to be under root, what was that? KW into C by which substance? Denominator will that substance which is weak in nature. Now apply log and then subtract. You people are genius. You can understand that one and tell me the final equation in the next class. If you do that one, I'll go for third case. If suppose, for example, you know, sir, no question of homework, nothing, simple, try to enjoy the class and hi bye. Third case will not be discussed. I'll go to the next topic. Is it clear? Go ahead. Write down this. Sit at home and repeat first of all what we have done in case of weak acid and strong base, and then just go on. The flow should be very systematic. If you properly follow my notes, you can go ahead. Nothing to worry. And final equation will be definitely pH minus some number. Why minus? Sir, 7 minus some number. As you said just now, 7 plus some number. There we'll get in the second case 7 minus some number. Answer is pH will be always less than 7. Over. Fine. That will stop here. Remaining discussion we'll do in the next class. Thank you. Assalamu alaikum.